Good morning, good afternoon, everyone. Thank you for joining our Tech Spark for this month. My name is Andrew. I am an account manager for our direct sales team here at Meanwhile USA, and also joined by Brian. He's our engineering manager. And today we have a very juicy topic for you guys. Unless you guys have been living under a rock, you should probably know what a data center is by now. So today we'll be looking at the various data center infrastructures and then also seeing where Meanwhile can potentially partake in this industry. So without further ado, let's go ahead and take a look at what the current infrastructure is, which is the high voltage AC data center.
So today we're going to talk about data center. Currently, there's you guys heard about AC data center and then DC data center. Okay, so AC data center now, you have many different power level rating. Okay, you heard about like 50 megawatt power or 30 megawatt power. Those are using for Amazon or NVIDIA use for cloud services. And some data center like only few megawatt. Okay, those are for banking system, hospital. Okay, and some even smaller entities or company that do cloud service. They may just do like 20 or 30 watt data center. So there are many different level of power rating in terms of data center for data center. Okay, and the slide is showing the infrastructure of the data center. A lot of them have a generator. Okay, you see there's a generator. So basically what it does is do the backup when AC power outage, the generator will kick in. Okay, so that there's no data loss to keep the server going. And you also see AC UPS. Okay, what it does is it's a UPS that can last for about 5 minutes or few minutes. Okay, when for the generator to start up. Okay, because the generator takes some time to start up. So when it start up, okay, the AC UPS when power outage, the UPS will kick in and the AC generator will start up. Okay, to do the backup. So that's why you have the AC UPS system there. And on the right hand side, you see a lot of high compute rack. Of course, those are the server where the GPU, CPU, power supply server built into it, where that is where all the heat are generated. And therefore, there is a lot of cooling, okay, cooling system. You see the red and blue line, those are the liquid cooling. That's where to circulate the heat out of the data center and go into a chiller. And the heat exchanger is usually used to pull the heat out of the compute rack. Okay.
And again, this is just kind of like a high level diagram or overview of what the inside of a data center looks like, in particular the high voltage AC data center. So before we jump into some potential Meanwhile opportunities, I want to make a quick disclaimer. So we actually don't power any of the actual, server power supplies or the GPU power supplies. And the main reason behind that is because this market is very, very saturated. There's a lot of competition, naturally that drives down profit margins. So what Meanwhile does, even though we can't partake in the meat and bones, so to say, we can there's still plenty of opportunities, those being in the peripheral kind of accessories and we'll take a look in just a moment.
Yeah, so in the next couple of slides, we will introduce some of the peripheral inside data center, like what I mentioned earlier, and the Meanwhile power supply that can use in those peripheral application. Okay, so let's take a look at the next one is the so AC UPS, right? Like I mentioned earlier, this is a peripheral. Okay, is a this UPS basically is installed in series with the 480 volt three phases line. Okay, is for the backup for the generator to start up. Okay, and they usually have like a charger, a battery, and inverter built in. Okay, efficiency is about 97%. So when there's a power outage, okay, the inverter will kick in and do the UPS backup. Okay, they are like on the right hand side, you see the photo. Okay, it's like a double side 19-inch rack. Basically, all the inverter charger are in there. Okay, it's one of those rack is about 250 kilowatt per module. And so, for example, if the data center is 2 megawatt power, you need like 8 of them. Okay, in parallel to do the few minutes backup for the generator to kick in.
So,
Okay.
I mean, these are like very, very high power, obviously 250 kilowatt stackable modules. I think that's a little bit outside of Meanwell's power capabilities, but do we have anything similar to this, maybe at a lower scale?
Yes. So meanwhile, we releases the a product line called online UPS. Okay, this is what exactly it does for, but in a lower power rating. Okay, the highest power rating we have now is 10 kilowatt. It's single phase in, single phase out. Okay, it can be used in a data center or a lower power data center or a server. Okay, and so like I mentioned earlier, a smaller entity who do cloud service that have the small data center can also use 4 or 5 of this inside the server to do for UPS backup. Okay.
Gotcha. Yeah. And if you guys have any questions about this ES-SU10K, feel free to drop some questions in the chat below.
Okay. And so here is another one case sharing that we used to work with a customer that they do AC UPS. Okay. And like I mentioned earlier, there's inverter and their charger built into the cabinet. So it gets quite hot. And this customer is use WDR480 and TDR480, 48 to power the fan. Okay. And one fan is like 50 watt. And then they have a lot of fans inside this cabinet. Okay, to do the cooling. So about like 8 per module. So they use a lot of unit.
Right. And also we have our new XTR series, which would be a great fit as well. That'll eventually be phasing out the TDR. So if you see any opportunities similar to this, please feel free to push our XTR 480 or 960 models. So that pretty much wraps up the UPS system for the high voltage AC data centers, kind of like the opportunities for Meanwell to partake in. So let's take a look at another peripheral, that being the rear door heat exchanger.
Yeah. So this one, every data center basically needed it's a basic liquid cool to cool down the center. It's you see pipe going underneath the data center to do the cooling, and rear door heat exchanger is another element that basically is like is the rack side is the 30U size that installed right next to or attached to the server rack. So what it does is basically pull the heat out of the server rack. Remember server rack, you have power supply in there, you have server in there, you have GPU, those a lot of heat. So the rear heat exchanger basically is to pull the heat out from it. Okay, it went into the heat exchanger and the liquid cool will cool down the high temp. Okay.
Gotcha. Yeah. So if you take a look at the diagram right here, you have the blue pipes that would be running in the cold water. And then in the middle, you kind of have this heat exchanger that's powered by a pump. And then that would be hooked up to that red pipe, which would be the return pipe for any of the warm or hot water. And so we'll take a look at
Yeah.
powering the pumps.
Yeah. So one of our customer application is they use three-phase XP30K to power the BLDC motor or basically the pump. Okay. What it does is they use the power supply to power the BLDC to pump the liquid. Okay. From the hot and the cold liquid circulating it. Okay. And they also able to control the flow by using one of our the CMU2 to control and monitor the voltage and current. Okay, so this is one of the application, and another application that we use to see is for the rear door heat exchanger, the DC fan. Okay, this customer use our rack power to power the fan. Okay, for the heat exchanger, every rear door heat exchanger they have like 8 fans on it, and the customer use like the rack power, multiple rack to power multiple of the rear door heat exchanger. So imagine one server rack, 30U, 42U, has one rear door heat exchanger attached to it. Okay. And if you have 50 of them, you have 50 of those rear door heat exchanger, and then a lot of DC fan running inside, and the rack power is basically to power those fan. Okay, to pull the heat out of the server rack.
So for this specific application, the liquid cooling is still present. This is kind of just an additional layer of cooling, right?
Yes.
That's by forced air.
Yes. So the fan is basically to pull the hot air out from the server rack.
Gotcha. Okay. Yeah, and I think before we move on to the next slide, let's go ahead and do a quick recap of the 2 categories that we mentioned. So there was the UPS system and also the rear door heat exchanger, right? So the UPS system, of course, we had the online UPS we mentioned. And then also, for lower scale, lower wattage UPS systems. And then also we talked about the fans to cool
Mhm.
down these UPS systems using potentially our TDR, WDR, or XTR. And then, of course, the rear door heat exchanger. So we had the thermal management system, the liquid cooling to drive the pumps using our
Mhm.
SHP30K. And then also on the screen here, you see the DC fans that help to cool down not only the server itself, but also the heat exchanger. So that would be using our NCP and DHP rack system.
Mhm.
Yeah.
Um,
Yeah, so and then moving on, so this is kind of where things get a little bit interesting. So we talked about the high voltage AC system. So just kind of simplifying, dumbing down this chart you see on the screen here, the AC system essentially takes utility power. So utility power is very, very high. So 13 to 35 kilovolts AC. So what happens is there's a transformer in between there that steps it down from that utility level power down to 480, and then there would be, a separate AC distribution panel that steps it down from 480 down to something more workable like 55, which would eventually go on to power the servers, right? The thing is about this setup, this infrastructure, is that in between that AC to DC step down, there's actually a UPS system, an AC UPS system, the one that we looked at earlier. So what happens here is due to the AC bypass, so when you're going from 480 to 480, there's actually a little bit of power loss, which can be up to
about like 3%
Three
credit in
percent,
order
three
stuff.
percent. And when you factor in the scale of these data centers, right? We talked about, I mean, the NVIDIAs of the world, OpenAIs, all of these big data center companies, they use, I mean, 50 megawatt plus, and each megawatt is 1,000 kilowatts. So that's a lot of power, and even 3% that can cost them millions and millions of dollars, year over year, right? So what NVIDIA has announced, or we're going off of kind of their public announcement, is that they're transitioning into this high voltage DC infrastructure. And what that means is they're stepping down that, high 13 to 35 kilovolt AC power. Now they're stepping that down directly to 800 volts DC. And they're doing that through the use of a solid state transformer. If you guys haven't heard of that before, it's kind of this essentially, it's a very high power specialized AC to DC converter that's able to step down, insanely high AC voltage down to 800 volts DC, which is what the new servers and DC buses would be operating off of. And the reason for them switching from the traditional AC infrastructure to this is because of efficiency. We've talked about that 3%, right? This will help them save money in the long run, save power, and then also it'll be more cost effective because 800 volts DC naturally, because of the high DC voltage, the current is going to be lower. The amperage is going to be lower. That means the cables they use to install these systems are going to be thinner and require less copper, and copper is very expensive. So it'll help them save on just overall cost when building these data centers.
Yeah, so to summarize, the 800 volt DC data center, the DC center is going to help, what it does is basically make the data center run more efficient, less heat generated, and also a save cost on wiring and copper. Okay, so that is basically the goal of the 800 the DC data center. Okay,
Yeah,
and let's look into the infrastructure of the DC. So now we're talking about DC. It's a little bit different as compared to the AC. The peripheral that you inside may change. Okay, so for example, Andrew mentioned earlier about the solid state transformer. So this is like it's I don't know why it's called transformer, but it doesn't have any like coil and stuff. But it's basically an AC to DC. So you still have a lot of power electronics component in there. That's gonna step down like three phases from AC down to 800 volt DC, and that 800 volt DC is gonna bring into the data center. Okay, and some elements are still there. So the computer rack still there. Okay, readout heat exchanger still there. Cooling system still there. Okay, what different is the UPS backup. Okay, because earlier we were talking about AC 480 volt UPS backup. For DC UPS backup, okay, to wait for the generator to start up, people use or they use the energy storage system. Okay, they changed it to 800 volt energy storage system. Okay, and another solution that to replace the generator is we're using fuel cell. Okay, some are talking about using fuel cell to do the backup. Okay, and that's gonna get rid of the generator and also the energy storage system. Okay, and then we will go over those later on the next couple slides. Okay. Uh, so this is a energy storage system. Okay, I think you guys heard about energy storage system. Basically, it's basically a lot of battery in there or inside container, different level of voltage. Okay, some of them you heard about 400 volt. Those are for industrial or commercial, small commercial use. 800 volt is what is basically used a lot for data center. Okay, and there's a higher level which is about 1000 or 1500 volt, 1000 to 1500 volt. Those are utility scale where like you install a lot of this energy storage inside or underneath the or nearby the substation. Okay, to do the peak saving and storage or high demand, the battery will kick in. But for data center, 800 volt is typically is the voltage that require. Okay, so you see energy storage, you see those there's on the input side, okay, on the primary side, and also there's a small one on the output side. So those two they have their own function. Okay, the one in the AC side, the primary side, installed right next to the generator is for to back up the generator. So when AC out, it's gonna kick in. Okay, for the generator to start up. Okay, those are 800 volt. And then you see the smaller one on the low end or the rack end. Those are smaller energy, smaller amp hour, but higher voltage too. At 800 volt, it's basically to observe any disturbance of the SST. Okay, so there's a spike or anything that they can the smaller energy storage going to observe it.
Yeah, so for the one on the left side, the utility level scale, unfortunately, we don't have anything for that. But for the 800 volt DC, the smaller energy storage systems, we definitely have some products that, can be a good fit for customers who need something for, stepping down 800 volt DC to 24 or 48 volts. So you can look into some products like our RSDH 150 or 300 volt or 300 watt, or our DDRH 120 or 240. And another instance of mineral products partaking in these energy storage systems is actually the inverter, so the NTN 5K. So quick story, I actually visited a customer yesterday who does something similar. So they have a 24 volt bus. They have their own DC-DC, high power DC-DC stepping down 800 to 24. And then they still needed an inverter for auxiliary power. So things like thermal management, powering fans, touch panels, solar PV farms. Basically, they needed a collective peak power of 3 kilowatts, and they were able to find our NTN 5K and spec that in, and that would basically power some smaller auxiliary power that is still necessary for their storage system.
Yeah, so I mean, for energy storage system, we don't have the charger that do 800 volt that high, but for auxiliary power, they need to step down from 800 volt or 1000 volt. RSDA, the DDI can do it. For BMS or for touch screen, and even if they have need AC power, like Andrew said, for pump or for light fixture, the NTN 5K is is a solution for it. Okay, so that is the energy storage system. The next one is we're gonna move into the fuel cell backup. So, like I said earlier, okay, generator, diesel generator take time to start up, and that's why you need a energy storage there. And some look into the fuel cell. Okay, the advantage of using fuel cell to replace the generator is that it can start up right away. Okay, there's no wait time. That means you can get rid of the energy storage. Okay, so the fuel cell, and then the fuel cell can run even quieter. Okay, and also can even last. Sometimes can even last longer. Okay, than the diesel. Same thing. Those are refillable. Okay, diesel. I mean, when diesel out, you have to refill the diesel. With the fuel cell, okay, what the main element is the hydrogen. Okay, for data center, okay, the hydrogen is preserved. Okay, the hydrogen tank is always there. Okay, and also the fuel cell is always there as well. It's basically they are inside another like 30-foot container. Okay, when it's then about power out. Okay, the hydrogen gonna supply to the fuel cell, and the fuel cell basically people stack a lot of them small one up to 800 volt. Okay, to power the generator, and and when there's the hydrogen is out, okay, they will have a deliver. Okay, a truck will deliver the hydrogen over to refill. Or another solution is they will bring the pipe in, okay, to automatic refill the hydrogen. So in other words, for data center, hydrogen does not generate on site. Okay, we know some application that hydrogen would generate on site, but for data center, it's just for power hours backup. Hydrogen does not generate on site. It's basically it's preserved there, and then if it's out, there's a truck that deliver over.
Mhm.
And why we bring up this one is we have application where customer use HSP 30K to do hydrogen. Okay, Andrew, maybe you can.
Yeah, yeah. So this is a customer. Again, this is where Meanwhile would come into play in that what Brian was describing about the hydrogen generation for data centers. So for this customer, they were building a large scale hydrogen electrolyzer and they required a lot of power. So what they did was they went through Meanwhile Power Solutions, who helped build them a pre-assembled turnkey power cabinet using 8 SHP 30K 55s in parallel. And then also they had a CMU2 up top, as you see in the picture, to help program and set the voltage and also program the startup as well. So as you can see, there's definitely opportunity for Meanwhile to partake in this category as well.
Yeah, so some just for data center, is hydrogen delivered, but some other application for fuel cell application, some even install like a solar farm next to the fuel cell generator to basically do the generate hydrogen on site. So
Hmm.
those are called green hydrogen, and then there's some like something about black hydrogen as well. But
Yeah.
like Andrew mentioned earlier, we do have a solution to for hydrogen generation, like the HXP 30K
Mhm.
to do PC and PV to control the current and voltage for hydrogen generation.
Right, right. And just a recap super quickly of the DC categories we talked about. So the peripheral categories we talked about. So we talked about the battery energy storage system. So those potentially using some high voltage DC-DC converters, right? Or RSDH or DDRH. And then also if they need auxiliary power, something like our NTN 5K would be a good fit. And then right here on the screen, we see hydrogen electrolyzer. So that would be something where maybe you require a bit more custom approach. Feel free to contact our Meanwhile Power Solutions reps if you come across an opportunity like this that requires a lot of power, anything 50 kilowatts, 100 kilowatts plus. As you can see, we can build something like this for you. And then if we just, before we wrap up, I guess we can do a general overview of everything
Hmm.
we went over. I think the key takeaway is that right now we are kind of in this transition period, right? So NVIDIA and OpenAI, they're developing the high voltage DC infrastructure, which is set to come in, maybe 2027, 2028 for initial prototypes, initial installations. But for now, they're using the high voltage AC, right? So utility power, step down to 480 volts AC. You have the AC UPS system, and then you're stepping that down to your 55 volt DC or whatever to power your servers. And then eventually, we're going to
Yeah.
transition into the solid state transformer.
Yeah, so I mean, regardless AC or DC data center, we do have a solution for those peripheral. Okay, and yeah, so reach out to us. I mean, if you have any other request like a DC to DC, and I think that's gonna wrap up our training today.
Yeah.
Right.
So if you guys have any questions, again, on the screen, you see our technical contacts. This is Brian, and then you can reach out to Kareem, Han, or Rongwei as well if you have any questions. And then I think we'll keep the call running for another few minutes. So feel free to leave your questions in the chat below. And of course, stay tuned for next month. We'll have another Tech Spark on Thursday, May 25th, where Ivy and Kareem, they will be talking about some of our smart LED drivers, in particular the SPWM. So make sure to mark your calendar for that. And that pretty much wraps up today's Tech Spark. Thank you so much for joining, and I hope you guys have a great rest of your day.
Thank you. Bye bye.
Thanks. Bye.